Hello everyone and welcome to lesson 3 of geometry. Today we're going to be talking all about angles and triangles. So I'm not sure how much of this sounds familiar to you already, but I'm going to tell you everything in today's lesson is very important to the rest of geometry. You're going to be using it a lot this year, and honestly it's some of the most basic and important concepts. So with that, let's get started by talking about the different types of angles we can have here. So the first kind of angle we can have is acute. An acute angle looks like this, and the secret to an acute angle. And so basically what that means is for the acute triangle, you have an angle less than 90 degrees. All the angles have to be, well, I guess the angle has to be less than 90 degrees. For a right angle, also Madavi, can you please mute yourself if you don't mind? For a right angle, the secret is the angle has to be exactly 90 degrees. And so that's what a right angle is. It has to be exactly 90 degrees. You can see this symbol right here, this little square right there. That means it's a right angle. So whenever you see that little symbol right there, it means it's a right angle. Then for the obtuse, obtuse simply means it's going to be greater than 90 degrees. And obviously you can see here that's greater than 90 because the 90 looks like an L shape. And then the straight angle kind of looks funny. The straight angle is going to look like this. Imagine two hands on a clock going in opposite directions. This one is exactly 180 degrees. And in a way, it doesn't even look like an angle. It looks like a straight line. But I'm telling you, this is called a straight angle, and it looks like a straight line. So now we have some special angles that we're going to have to know for geometry. And honestly, these are some things that are going to show up on the SAT. And I remember, because I tutor SAT all the time, whenever I have students and we come across a geometry question and the answer involves one of the three right here, they never know it and it makes me upset every time. So you guys get a head start. You guys are going to be smarter than my SAT students after today. So congratulations. You just cleared a very low bar. So anyways, with complementary, the secret is they add up to 90 degrees. Add up to 90 degrees. Remember, that's the right angle. So that would be an example like this. Let's say I have this angle, and I have x, and I have y. Now what I'm saying is if these are complementary angles, then x plus y must add up and equal 90 degrees. That's the secret to complementary. And we're going to be doing that a lot today. Next, we have supplementary angles. Supplementary, these are angles that add up to 180 degrees. And here's an example that looks like that. Notice this is a straight angle. And if I just add an extra line, like right there, for instance, and I call this angle x and this angle here y, what I would say is x plus y is equal to 180 degrees. And then the last kind of special angle we have is the vertical angle. I don't have a good explanation for this other than you have this kind of X shape right here, intersecting lines. And when I'm telling you this angle right here, if that's X and this angle here is Y, then I'm telling you X is congruent to Y. Remember that congruent is just another word for equals. So I'm saying the two are equal to each other. And by the way, if you want to say that these two angles, let's call this angle A and this angle B, you could also say angle A is congruent to angle B. Any questions on that first page? Nope. Okay,
Okay,
then
what
great.
are vertical again?
Yes, vertical angles are angles across from each other. See how X and Y are across from each other and A and B are across from each other? And if they are vertical angles, the secret is they are congruent.
Okay.
And we're going to be looking at a lot of those today, so you'll get some practice. So that's it for the special kinds of angles. The next thing we're going to talk about is triangles. So triangles are probably the most important topic in all of calculus, not calculus, geometry. What am I talking about? And triangles are special because there's a bunch of special things that we're going to know about them. Yes, squares are special too, trapezoids, pentagons, all those shapes are special, but we end up spending the most time in geometry talking about triangles more than any other shape. So the first thing we're going to say about why triangles are special is number one, all angles in a triangle add up to 180 degrees. So for instance, in this triangle I have right here, you see 63, 77, and 40 degrees. Well, if you take a calculator and you add 63 plus 77 plus 40, I promise you you're going to get 180 degrees. Same thing here for this triangle right here. You have 30 degrees plus 60 degrees plus 90 degrees. That is also going to equal 180. So once again, this is a true triangle. What I'm basically saying is, let's say the angles didn't add up to 180. Well, then that's not a triangle, and the problem would be incorrect somehow. The second property we have is, and this is specifically for right triangles, and remember, a right triangle simply means it has a 90-degree angle. We already know what a 90-degree angle is. Then we can use Pythagorean theorem. Now, maybe some of you have heard Pythagorean theorem before. I'm going to tell you it's probably the #1 theorem or formula you learn in geometry ever. So the formula goes like this. Pythagorean theorem says a squared plus b squared equals c squared. Maybe you've heard of this before. Where a squared and b squared, these are the legs of the triangle. In other words, the bottom or the side. And c is specifically called the hypotenuse. The hypotenuse is always the side that's across from the right angle. So in other words, in this triangle, this c right here, that's the hypotenuse because it's across on the other side from the right angle. The hypotenuse is also special because it will always be the longest side of your triangle. That's a fun fact. So in this example we have here, you can say this leg is A. You can call side B the 3 side. And what I'm saying is, if a squared plus b squared equals c squared, then what that means is 4 squared plus 3 squared equals c squared. And you can reduce this to 16 plus 9 equals c squared. 16 plus 9 is 25 equals c squared. And then you just have to take the square root, and hopefully you know the square root of 25, and it's just 5. So there we go. We just found the hypotenuse. It's c. And by the way, if let's say it was a square root that you didn't know, for this lesson today, I'm fine if you just leave it as a weird square root that you don't know. I'm fine with that. Sometimes you can simplify square roots, but that's not the focus of today's lesson, so I'm not going to worry about that too much. Now, the other note, the last note I want to say, is that for Pythagorean theorem, A and B, sides A and sides B, are interchangeable. Interchangeable. All that means is that you can switch them around. So for instance, in the last problem, you could have said 3 squared plus 4 squared equals c squared, and you'll get the exact same answer, I promise. Any questions on Pythagorean theorem? Okay, great. Now let's look at some examples about everything we just talked about. So #1, we have this kind of shape right here. We got a lot of angles going on, as you can see. And the first question is, what is the sum of A and B? So here's what I would tell you. This looks like a straight angle, right? The long, straight one? Exactly. So a straight angle, remember, that's 180 degrees. You see that we have a 90-degree angle right there because of the square, which means the last side, this A and B combined, has to be 90 degrees as well. The reason why is because 90 plus 90 equals 180. So together, A plus B must equal 180. And so that's the sum. It's going to be 180. Not 180. What am I saying? I meant 90. I apologize. 90 degrees, because they add up together to make 180 with this 90 right here. Okay, now part B is the important question. If A is 25 degrees, I'll just fill that in right here. If A is 25 degrees, what is the value of B? So like we just said, they have to add up to 90. That means 25 plus B equals 90. Subtract 25 from both sides. In other words, 90 minus 25, that's going to be 65. So B is, that's a degree symbol, a poorly drawn one. B is going to be 65 degrees. Any questions on that first one? Okay, then good. The next one, #2, this one's going to be much more complicated. I'm just going to warn you now. So we have this crazy kind of shape looking right here. There's a lot going on here. It also says, given that measure of angle OJN is 50 degrees and PM is perpendicular to NK, what is the angle measure of X, Y, and Z? So let's start off by plugging in or filling in the 50-degree angle at OJN. Here's O, here's J, here's N, which means what they're saying is this right here is our 50-degree angle. Now the order doesn't matter. You can find x, y, or z first. It doesn't matter. I would recommend finding x first because this is going to be the easiest one to find. Why? Because if you look closely, x is a vertical angle. And why is it a vertical angle? Because remember, vertical angles come from intersecting lines. Let me highlight that in red here. See how the 50 degrees is encapsulated by the two red lines I drew? And because of that, they're vertical angles, so that means x is equal to 50 degrees. Any questions there? Okay, then good. The next thing we
Actually,
can do,
don't get that method. You know,
you want me to explain it another way?
yeah.
Okay, so basically, let me just draw this shape, ignoring every angle except for the 50 degrees in x. Let me draw the only thing as the 50-degree angle here and x here. Now what I'm saying is, based on this picture, because these lines intersect, they are called vertical angles. And if you were to get your protractor out, I'm just telling you, that is going to be equal to each other. So x is automatically 50 degrees. That is the rule for vertical
Because
angles.
split into half.
What'd you say? Oh yeah,
Because
you
it's
can
split
you
into
can think
half,
of it
right?
as being cut in half, but it's not exactly cut in half because then it'd be 25 degrees. The better way to say it is that they intersect each other, forming two identical angles.
They're saying that they're congruent to
Yes,
each other.
I'm saying they're congruent. Does that make
They're
sense?
congruent. So if they're congruent, one's automatically the same value, right?
Yes, because remember, congruent in geometry, congruent is the same thing as equal to. And that's why they two have to be equal to 50 degrees. So now the next thing we're going to do is we're going to find the measure of angle y. So to do that, I'm going to erase those red lines I drew to make it easier for myself. Now, right now, there's no way of finding measure of angle y because it's not a vertical angle. But one thing we do know is that PM, which is, now let me draw that in blue, PM in blue is perpendicular to NK, which I'll also draw in blue. And remember what perpendicular means. Perpendicular means that it forms 90-degree angles. It forms 90-degree angles. You can also call them right angles. They're the exact same thing, which means every angle that you see in blue, the four angles you see in blue, between the blue, those are all going to be 90 degrees. I'll show you in green now. So what I'm saying is this is 90 degrees, this is 90 degrees, and so are the other two on the other sides that I don't want to draw right now because it's going to mess up my picture. But because of that, I know that x and y form 90-degree angles. Remember, that means they're complementary because x and y adding to 90 means they're complementary. So that's what I'll write on my paper. X and y are complementary. And remember, x plus y would therefore equal 90 degrees because that's what complementary is. And we just found x a second ago. We said x was 50, which means 50 plus y equals 90. Subtract 50 from both sides. Y is going to equal 40 degrees. Okay, so we have x, we have y. Now we just need one more. We need z. So to find z, again, I'm going to erase my line so I have more room to write. And what I would say is, if you want to find z, there's actually two different things you can do. One is you can say it's complementary with the 50 here. Z is complementary with the 50. Or the other thing you can say is z is vertical with y. And why are they vertical? Because again, let me highlight these in red between z and y. And you'll see that they are intersecting. That means because they're intersecting and they're opposite sides, they are vertical, which makes them congruent, which basically means they're equal. Basically what I'm saying is z must equal y, which was 40 degrees, so that's what z is. Any questions on x, y, or z for this problem?
Can you repeat the explanation again? I wasn't
Yes, so there's two explanations I could have done actually. I didn't finish the first one. The first one I could have said was z plus 50 equals 90 because they're complementary. So in other words, z plus 50 equals 90. Subtract 50, z equals 40. That's the one I didn't say, but that's another way you can prove it. The easier way, with less math, is just saying z must be congruent to y because they are vertical angles. And that's going to be the word of the day today, vertical angles, because they're intersecting and they're on opposite sides, which means they're congruent to each other. Does that make
Um,
sense?
yes. So it's the same explanation like for like lines for the angles OJ and N and LJ and K. Correct.
Yes. In other words, how we found x is what you're saying, right?
Yes.
Exactly. Okay. So with that, we're going to move on to the next page. Now for this one, we've got a new problem on our hands. In all the problems in problem 3, I'm going to give you 2 angles of a triangle. You need to tell me what the third angle is, and then you need to state whether the triangle is acute, obtuse, or right, which I'll help you with that. So for this first one here, 25, 100, what's the missing angle? Remember, all triangles have to add up to 180 degrees. So I'm going to say 25 plus 100 plus x, the missing angle, must equal 180. And now it's just an algebra problem. So 25 plus 100 is 125 plus x equals 180. We're going to subtract 125 from both sides. Easy peasy. You're going to get a final answer of 55 degrees. So that's the missing side. Now the last question we need to answer is this triangle acute, obtuse, or right? Basically, the easiest way to answer this is you need to say if it's greater than, less than, or equal to 90 degrees for any of the angles. I'm looking at 100 degrees right here, and I'm saying 100 degrees is greater than 90, and so for that reason, it's going to be an obtuse triangle. You only need one angle to be greater than 90 in order to get obtuse. And so for that reason, 100 is greater than 90, it's obtuse. Let's say they were all less than 90, then it would be acute. Or if one of your angles was 90, then that would be the right triangle. And that's the only 3 situations you can have.
Wait, if even if one of your angles was 90, it would be a right triangle?
Yes, you only need one angle to be right to be a right triangle. That's correct. As a matter of fact, it's impossible to have 2 right angles for a triangle. Let me prove it on this page. So let's say the first 2 angles are 90, plus 90. The third one's what you're solving for. And remember, all angles have to add up to 180 degrees. So 90 plus 90 is 180, plus x equals 180. When you subtract 180 from both sides, you get x equals 0. You cannot have a 0-degree angle. That would be an impossible triangle. And for the same reason, you cannot have 2 obtuse angles. That's impossible as well, because then you'll get a negative angle for x, and that's even worse.
Uh-oh.
So in other words, if you have at least really just one angle that's 90 or one angle that's obtuse, the whole thing is obtuse or right, or acute needs to be all 3 less than. So with that, let's move on to part B. For part B, the angles are 64, 26, so I add them together, and then I add x, and together they're going to equal 180. So 64 plus 26, that's going to be 90, plus x equals 180. Subtract 90 from both sides. Looks like we get x equals 90. The missing side was 90. And as we just said, since one of the angles is 90, that's going to be a right triangle, just like that. Then for the next one, 89 plus 17 plus x must equal 180. 89 plus 17, that's going to be 106 plus x equals 180. And then you subtract 106 from both sides. And yes, it helps if you have a calculator, which usually they let you do for these. But if not, this is simple subtraction. I hopefully don't have to explain it to you at this point in your math careers. But it's going to be 74 degrees. Now for this one, notice 89, 17, 74. All of these are less than 90 degrees. For that reason, this is acute, because all of them are less than 90 degrees. You'll notice 89 is close, but not 90, so it's still acute. And then for the last one, we have 5, 5, and question mark. That means 5 plus 5 plus x equals 180. 5 plus 5 is 10, so 10 plus x equals 180. And then you just subtract 10. X is going to be 170 degrees, which is a very big angle, nearly a straight angle. And because it's bigger than 90, that's going to be an obtuse triangle. Any questions on any of those for number 3?
You're kind of going too fast.
I'm sorry, I'll slow down. Also, the good news is since I'm recording, you can always go back and watch it for yourself, and you can always ask questions or email me if it still doesn't make sense.
Okay.
So for the next part, we're going to be talking about congruent and similar triangles, which basically congruent we talked about before means equal in geometry. And if you want to say two triangles are congruent, in other words, equal, then you need to have, and we wrote it down right here for you, they need to have the same three side lengths and the same three angle measures. That's the only way they can be congruent. That's the only way they can be equal. So as you can see here, you have triangle ABC. That's how you'd write a triangle. It's a little triangle symbol. I'm going to try and draw that better because that was kind of pathetic. Triangle ABC. And then over here you have triangle DEF. Also, another thing worth mentioning, the order matters. In other words, see how angle A is touching angle 67 and angle D is touching 67, and they're both first in the order? That matters, actually, when you write out your triangle. So for instance, if I want to say these two triangles are congruent to each other, which they are, by the way, even though it's reflected, it doesn't matter, they're still congruent. What I would say is triangle ABC is congruent, that symbol, to triangle DEF. So the note I want to make here is you can reflect or rotate and still be congruent. That is absolutely okay. You
Isn't
can,
that a rigid motion?
can you repeat that?
Isn't that some rigid motion or something?
Yes. So that's also known as transformations or rigid motion. That is, I forget if we talk about that in the summer course or not. But for right now, we're just saying that you can reflect it, rotate it, and it's still congruent. That's absolutely okay. Now, by the way, you can look at the triangle to the right here. Notice I didn't put any angles here, but all of the side lengths are congruent. And what I have a note at the bottom here, you can still prove two triangles are congruent by the side lengths alone. In other words, you don't even need the angles, because one thing that's true in geometry, and this is true for all triangles, if the side lengths are congruent, then the whole thing is automatically congruent. Doesn't matter about the angles. As a matter of fact, I promise you, the angles will match. So for instance, between 5 and 13 is the 67-degree angle, which means the 67-degree angle will go right there. I promise you. The 90-degree angle, go ahead.
Wait, so what were you saying?
I'm saying that between the 5 and the 13, see right here, between 5 and 13 is the 67-degree angle. That is going to be the same as angle G on this triangle to the right because they match. Let me finish explaining and then you can ask questions. So 5 is also, between 5 and 12 is our 90. That's angle H right here. That's going to be 90 degrees. And then between 13 and 12, here and here, that is going to be 23 degrees. And that's how it matches up. Any questions there?
So wait, the same lengths are in the oh.
Yeah, triangle GHI is congruent to the other two triangles I already said. And the reason why is because their side lengths are congruent, and because their side lengths are congruent, automatically their angles are congruent as well.
Okay.
And with that, we're going to move on to the next topic, which is similar triangles. So similar triangles have the same three angles, but different side lengths. Look at these two triangles right here. See how they're different side lengths to each other? We would call them similar because the angles are identical, 67, 90, and 23, but the side lengths are different, and that's important. And basically what similar triangles mean is that similar triangles are proportional to another. What does proportional mean? It means one is bigger and the other is smaller, but they are identical in size. So imagine you have a model ship, right? Imagine you have a model ship in a bottle, right? That model is just a smaller version of the big ship, and that's exactly what similar triangles are. This little triangle is just a model of the bigger triangle, and so we would say they are similar. And the way you would write that is you would say triangle, ABC is similar. This is the symbol for similar. It's just a little a tilde. Okay, that's all what similar means. And I ran out of room, so let me move it over a little bit so I can finish writing that.
JKL.
Go ahead.
So you're saying that triangle ABC is similar to triangle JKL.
Exactly. Because the angles are all the same. The other thing I want to tell you is that the side lengths will be proportional to each other. What does that mean? So basically, let me write on a new page. The side lengths were, for the smaller one, 5, 12, 13. For the bigger triangle, the side lengths were 10, 24, 26. What I'm saying is if I make fractions out of the matching side lengths, which is this one, and this one match, they're going to be the same fraction. Let me prove it. 5 over 10 equals 12 over 24 equals 13 over 26. All of these fractions are 1/2. And because they're all 1/2, that's another reason why they are similar. It's not the only reason why. It was also because their angles were similar. And so now let's look at some examples of this. So for the examples number 4, determine if the triangles are congruent, similar, or neither. So for this one, as you can see, my side lengths are 7, 6, and 10. Over here, my side lengths are 7, 6, and 10, which means I don't even care about the angles. By the way, what these angle symbols mean, it means that these angles are congruent, these angles are congruent, and the two marks are congruent. That's what that means. But I didn't even need that because the side lengths are the same, and because the side lengths are the same, then that means the two triangles must be congruent to each other.
It's a rotation of 180 degrees.
It is a
Right?
rotation, and the good news is I don't even care because rotations are not important for congruent. If anything, I'm just doing that to confuse you. And clearly, there's no reason to be confused because all you need to look at is the side lengths.
Right.
Now let's do another example. Number 5. Number 5, I give you less information. I give you a couple side lengths. I give you some angles. Now, right away, you should say this is not congruent. Not congruent. How do I know? Immediately, this side length is different from that one. This one's different from that one. Immediately, I know they are not congruent. They can be similar, but they can't be congruent because the side lengths are different. Now, does it matter that this hypotenuse is missing? No, it doesn't matter. We can find it if we want. I don't really care right now. I'm not going to worry about it. All I'm going to worry about is can I prove the angles are the same? Because if the angles are the same, then that means it's going to be similar. If the angles are different, then it's nothing. It's not congruent. It's not similar. Now, obviously, 31 is not equal to 59, but what I want you to notice is that all angles in a triangle add up to 180. So what I'm saying is this square right here, that means it's a 90-degree angle. We'll call the missing one x. So what I'm saying is 31 plus 90 plus x, that must equal 180. So 31 plus 90 is 121 plus x equals 180. And if you subtract 121 from both sides, you will get 59 degrees. So if we want to, we can fill in 59 degrees for that angle right there. That's poorly written. Let me try that again. That angle right there is 59 degrees. Now, as you can see, this one's also 59 degrees, which basically means that if I wanted to, I could do the exact same thing, 59 plus 90 plus x, this missing angle right here. That has to equal 180. But basically what I'm telling you is the only way this could have happened is if this angle right here is also 31 degrees. If you don't believe me, you can do it on your own. 31 plus 59 plus the 90 right here, that must equal 180. Basically what I'm saying is all these angles are the same now. I proved it. And because the angles are all the same, that means automatically these triangles are similar. Which, by the way, this also means that the side lengths are going to be proportional to each other. If we forget what that means, what I'm saying is for the little triangle, it was 3, 5, blank. You're going to say question mark. And the other one was, what was it? It was 9, 15, 3 root 34, which looks kind of confusing. But basically what I'm saying is 3 over 9 must equal 5 over 15, which must equal that question mark, I'm just going to call it x again, x over 3 root 34. Now, 3 over 9 reduces to 1/3. 5 over 15 reduces to 1/3, which means the last angle must also equal 1/3. I can solve this actually pretty easily. X over 3 root 34 must equal 1/3. That's what we're saying. If you want to solve for x, you can cross multiply, which basically means 3x is going to equal 3 root 34 times 1, which is just 3 root 34. And then we would say the 3's cancel right here, or you could divide out 3, which means x, the missing side, must have been equal to the square root of 34. And that's what the missing side was if the question asked for that. So that's more of a fun fact. Any questions on that one, number 5?
Is this math even required?
Is this
This
what even
this
required?
fun fact you just showed, is this even required for like in the future?
Absolutely. I'm only asking, basically, number 5 was asking, are the triangles congruent, similar, or nothing? If I tell you any piece of additional knowledge, and it's like a fun fact, then there's a good chance that you're going to be using it at some point in geometry. And I promise you that at some point you're going to be asked, they're going to tell you the triangles are similar, and you're going to ask to find the missing side. And how are you going to prove it? You need to use the fact that the angles, the side lengths are proportional to one another. And so you're definitely
Okay.
going to see that next year.
You mean this school year?
Yes, not during the summer. So like in the fall or spring.
Fall, winter, and spring.
Yes. So next is number 6. Use Pythagorean theorem to find the missing side. Simplify your answers as much as possible. So for this one, we have triangle number 6. We have 4, 2, and the missing side, which I will call C. If you remember, Pythagorean theorem says a squared plus b squared equals c squared. And it doesn't matter what I call a and b. They can be mixed up, switched, whatever. Let's say 4 is a, 2 is b, and we're solving for c. So that means 4 squared plus 2 squared equals c squared. So 4 squared is 16 plus 2 squared is 4 equals c squared. 16 plus 4 is going to be 20. So that means 20 equals c squared. And then you just take the square root of both sides. So the missing side length was the square root of 20. And you can just leave it like that. Technically, the square root of 20 can be simplified. I can show you at the very end if you want to stick around, and I can show you. But for right now, I'm
It's going
fine
to be a
with just
decimal.
being root 20. It will be a decimal, but what I'm saying is there's ways you can do it that you can break it up into different fractions. You probably learned this in algebra. I'm not sure if you learned it in Algebra 1 or Algebra 2. I remember I learned it in Algebra 1. But I can show you at the end if you're still curious. What I'm saying is root 20 is fine for today and for the homework. And then for number 7, we're basically doing the same idea. Let's call 12a. Let's call the missing side B. And let's call the hypotenuse, the 13, side C. Again, I'm going to say a squared plus b squared equals c squared. This time, it's going to be 12 squared plus b squared equals 13 squared. So then 12 squared is going to be 144 plus b squared, which is unknown, is equal to 13 squared. 13 squared is going to be 169. And again, this helps if you have a calculator. I don't care about sharing this information with you right now because I'm so nice. But then we're going to, if you want to solve for b squared, subtract 144 from both sides. 169 minus 144, that's going to be 25. And again, you just take the square root. So that means b is going to equal the square root of 25, which hopefully you know is 5. And there was the missing side. It's 5. Any questions for number 7? Okay. Number 8. Number 8, we have another triangle. This is the last 2 problems of the night. We're almost done. But we've got another Pythagorean theorem question. For number 8, you see one of the side lengths has a square root in it. It's a little scary, but don't worry. We're going to be fine. So side length, this one we'll call A. This side length we'll call B. The missing one we'll call C. So for this one, again, I'm using Pythagorean theorem. It's going to be a squared, which is 7 squared, plus root 15 squared, which I'll tell you how to simplify in a second, equals c squared, the missing side. So 7 squared is going to be 49 plus, whenever you have a square root and you square it, the square root just goes away. That's a neat little trick for us. And that's equal to c squared. So that means 49 plus 15. 49 plus 15 is 64, equals c squared. Take the square root of both sides. That means c is going to equal 8. And there's our missing side. It's 8. Any questions on number 8? Madavi, if you don't mind muting yourself, please, that'd be appreciated.
Animatronic.
And then for the last one, number 9, we have, again, we can call it A, B, and C. And so for this one, 9 squared plus the missing one, B squared, is equal to 9 root 2 squared. This is going to be the hardest one of how to deal with. We'll deal with it, don't worry. So first 9 squared, that's just 81, plus b squared, which is what we're solving for, equals. Now this is the challenging one. When you want to square something like this, 9 root 2, the secret is you need to square both. You need to square the 9, and you need to square the root 2, just like this, okay? Now 9 squared is 81, and root 2 squared, remember what I just said a second ago, when you square a square root, that's a tongue twister, when you square a square root, the square root goes away. So it's just 81 times 2. 81 times 2, that's 162, equals 81 plus b squared. We got the same thing on the left side still. And then all I need to do is subtract 81 from both sides. 162 minus 81, that's actually just 81. And we know the square root of 81, thank goodness. That's just going to be 9. And so the missing side is 9. Any questions on that one? Okay, then with that, that's going to conclude today's lesson. If you do have any more questions, please stick around for the end. I'd be happy to answer them. If not, have a great night. One thing I do want to say, next week is 4th of July. I will not be tutoring 4th of July night. I'm going to have to move the lesson. I'm probably going to move it to Wednesday at 7:30. Just move it back 24 hours. And I'll send out an email explaining all of that, so don't worry. So thank you all for attending. I'll see you next week. Take care, and bye-bye.